All right, I want to do a quick example of a language, a formal language, defined recursively. So we're going to take the same vocabulary as in the previous examples, A, B, C, and we're going to define L recursively by this base case that says that the empty string, lambda, is an element of L, and also X is an element of L for any element X. It's for any character X in the vocabulary. So that means A. Let's start figuring out what L is going to be down here. L is going to have lambda. It's going to have A, singleton, B, and C as well. So that's all just by the base case. But then it has this recursion rule that says if W is a word which is already in the language, and X is a character from the vocabulary, then XWX is an element of our language L. This recursion rule might look familiar to you because I've actually shown you this exact example before, but just without telling you it was a formal language. Let's see what happens when we apply this recursion rule. We can take any word that we already have in our language here and apply XWX with any particular symbol X. So for example, if you take lambda as your word, W, and you take A as your X, you do A lambda A. And you notice I didn't write lambda because concatenating with lambda doesn't have any effect, right? It's basically like blank. So AA can be achieved by this recursion rule. Pairing lambda as our word with the symbol B would give us BB, and we can also get CC. But then we could use one of these other base case words like B, A, B, or C. And so we can get words like AAA and BAB and CAC from choosing A as our W. Or we could choose B as our word W and get ABA, BBB, and CBC. Or we could use C and get ACA, BCB, or CCC. And that's just strings of length 3. So that's our first application of the recursion rule, and then we can take any of those strings we got and then apply the recursion rule again, throwing an X on the front and the back, etc., forever, producing an infinite set. And this language is a language in which the only admissible words are palindromes, using the letters A, B, and C. This was a problem I gave you earlier this semester on an assessment. So that's an example of how you could define a formal language. I just wanted to show you these couple of examples at the beginning here, just to give you this notion that formal languages can be defined in a lot of different ways. But the main topic of this section is something called the phrase structure grammar. So in the next video, I'm going to define that and show you some examples.